So our last example today is example 6. Once again, we have a natural log, so we want to start with our base function, remembering that there is an invisible e there, and if that helps us to write it in exponential format, we certainly can do that by starting with the base, going across the equals, and then finishing the circle. So as I put the values into my table, I'm going to remind you one final time for the day that these values of -1, 0, 1 being already in the y column will not be there in tonight's assignment. So you'll need to know that when it's a logarithm graph, whether it's a natural log or whether it's a common log, which is what we call the ones with log, those kinds of logarithms, in the future you will need to remember what values to put in for y. So e to the 0 is 1. That one's easy. E to the first is that memorized value of 2.72, and e to the negative first is another memorized value. So these two values of 0.37 and 2.72 you should memorize this evening and make sure that that's in your wheelhouse before we take our quiz. So we'll graph those points, and you need to pause because I graph them more quickly than you can. Feel free. Okay. Label that as my first graph. So one of the other things I want to notice is that there's a reflection outside, right? And if it's outside, that means it goes over the x-axis. And when it's inside, that means it goes over the y-axis. Just as a remembrance as to why that is, things that are on the inside affect the x, and in order to affect the x, you would have to go over the y-axis. In order to change this x value, if you bring it here, you didn't change the x value. In order to change the x value, you have to go over the y-axis. Doesn't matter which of these reflections I do first. Since I wrote the over the x-axis first, I will choose to do it first. So bring this point over the x-axis from +1 to -1. Take the one from -1 to +1. That's my second graph, so I'm going to number it, so I remember which points to move next. So when I go to reflect over the y-axis, I need to move from my most recent graph, not the original graph. This is 2.72 to the right. I want to move 2.72 negative of 0, left of 0. This is 1 to the right, so 1 to the left. 0.37 to the right, so 0.37 to the left. Then I will connect those. In this case, I'll actually be able to do the final smooth curve because there are no horizontal shifts and there are no vertical shifts either. So remembering that horizontal shifts are connected to my asymptote, since there's no shift, I would expect it to be at the original location, which is x is 0, and it certainly seems like that fits. And again, what I said is when you get to this and it's hard to read because you're not using a purple pen, you might want to extend it a little bit out so that I know where you've placed that. The domain is also connected, so it's horizontal shift, asymptote, and domain for logarithmic functions. And what I want to see is, are we on the left of 0 or the right? And I would say the points for the purple graph are to the left of 0, so all of the numbers you want are smaller than 0. And then our last component for this problem is to come up with the range, but we know that the range for logarithmic functions is always negative infinity to infinity, and since this is a natural log, it fits that